Hello and welcome to the 5 types of chemical reactions. My name is Liam. Our first chemical reaction is a synthesis reaction. This reaction occurs when two elements or compounds combine to form a singular compound. One example that we can see in everyday life is the creation of water. In the equation, there are 2 hydrogen and 2 oxygen. These elements come in a pair because they're diatomic elements. The product will be the compound H2O because it is a synthesis reaction. To balance this equation, we add a coefficient of 2 to the hydrogen and the H2O in order to have 4 hydrogen molecules and 2 oxygen molecules on each side. Water is essential to all living organisms' survival and is consumed every day in order to survive. The second chemical reaction is the decomposition reaction, which is when a complex substance is broken down into 2 or more simpler substances. A real-world example is the breakdown of carbonic acid. In the equation, the compound H2CO3 is broken down since it is a decomposition reaction into H2O, which is water, and CO2, which is carbon dioxide. The equation is already balanced and can be left as is. In everyday life, anytime you open a can of soda, the carbonic acid is broken down and fizzes out when opened in a can. This causes the production of H2O and CO2. The third reaction is the single replacement reaction, when one element replaces another element in a compound to form a new compound. A real-world example is the reaction of bromine and potassium iodide to form potassium bromine and iodine. The equation would have the compound potassium iodide and bromine. Then bromine replaces iodine in the compound Ki to form KBr. In order to balance the equation, we double the potassium and iodide on the reactant side and double the potassium on bromide on the product side. This gives a coefficient of 2 in front of Ki, KBr. This relates to real life because iodine can be used to clean cuts and wounds. The next reaction is the double replacement reaction. This is when ions from 2 reactant compounds switch places. In the real world, one example is the reaction of sulfuric acid with barium hydroxide to produce barium sulfate and water. In the equation, on the reactant side, there are the 2 compounds BaOH2 plus H2SO4. Then, since this is a double replacement reaction, ions from both compounds switch places to form BaSO4 plus H2O. To balance the equation, you add a coefficient of 2 to hydrogen to balance each side. In everyday life, this double replacement reaction allows you to filter the water you drink. The last reaction is the combustion reaction, which involves the combustion of hydrocarbons. The products will always be CO2 and H2O. With heat, and the reactants are always hydrocarbons and oxygen. One example in the real world is when lighting a stove, there is a combustion of methane, which reacts with oxygen to create a flame. The CH4 is methane, and when it comes into contact with 2 O2 molecules, it produces CO2 and 2 H2O molecules. This produces heat and fire. To balance the equation, we add a coefficient of 2 to H2O in order to equal the number of hydrogen atoms on the opposite side. This relates to everyday life because every time you use a gas-powered stove to cook, this reaction occurs.